This video demonstrates how to program single board computers, SBCs, with CASP remote build feature. For this demonstration we use Raspberry Pi 4 running Raspbian OS and Aaeon Up x86 board, running Ubuntu x86 and Windows 11 operating systems. We also take help of Arduino Uno to demonstrate the capabilities of the SBCs in communicating with the embedded microcontrollers via serial communication. Respective target board support packages shall be installed before building models. Please refer our earlier tutorials on how to install CASP board support packages. For this demonstration we run a trained machine learning model that recognizes handwritten digits and displays the recognized digit on a 7-segmented display. A webcam is used to capture the frames and send them to the SBC where the frames are suitably processed and fed to a trained feed-forward neural network. The feed-forward neural network recognizes the digits and sends suitable commands to display the recognized digits to an Arduino Uno board connected to the USB port of SBC. Arduino Uno is programmed to display the digit received from the serial port on a 7-segmented display. We use existing machine learning tutorial project and modify the model suitably for running on single board computers. Select MNIST number recognition workspace file and enable relevant blocks to train the model for handwritten digit recognition on the host PC. Enable learning in the feed-forward neural net block. Refer to our previous video tutorial on machine learning for better understanding of these blocks. Configure suitable simulation settings. Build and run the model. As you can see, the model has started the training on MNIST number dataset. Enable saving and loading of the trained model. Let the model be trained to a reasonable accuracy. Add some variations to the images during the training process. Training can be stopped after a sufficient accuracy is reached. We now modify the model to use the trained neural network for recognizing handwritten digits from the live video frames captured by the USB camera. Build and run the model. Show some random handwritten digits in front of the camera. The recognized digit will be displayed in the left sub-window 4. If no digit is recognized, it will display -1. The model seems recognizing the digits with reasonable accuracy. We now try to display the recognized digit on a 7-segmented display connected to Arduino Uno board. Connect a 7-segmented display to Arduino Uno as shown in this figure, and configure the pins in the model accordingly. Build the model and program the board. Configure simulation hardware for communicating with the board and test for proper operation. Run the digit recognition model again, enabling the display of recognized digit in the 7-segmented display. Model seems working as intended. Now, we run the trained neural net model on a Raspberry Pi 4. We connect a compatible USB camera and shift the programmed Arduino Uno to the Raspberry Pi. In the simulation settings, change the target to Raspberry Pi 4 remote build. Choose network camera instead of native camera. CASP remote build feature requires the required target tool chain be first set up on the remote target before building and running the models. Generate the remote build tool chain. Select the parent directory to which tool chain shall be generated. Enter parent path on the target system. This is required only for Linux-based targets. A remote build tool chain folder is created in the selected parent directory. Compress the generated folder and transfer the file to the target. On the target system, unpack the folder and open the readme_setup text file. Install the OpenCV dependencies by typing the commands shown in the file. Follow the step-by-step procedure to configure CASP remote build on the target. Trail run the simulation panel to ensure everything is set up properly. To access the serial port, user account may need to be added to the dial-out group and set up required permissions. Start the CASP or build process with correct IP address. On the host side, enter the target hardware ID. Configure the remote target IP address. And set port alias for the USB port. Start the build process. The build process should start on the remote target. After the build process is completed, CASP simulation panel should start running automatically on the remote target. As you can see, the handwritten digit recognition machine learning model is running satisfactorily on the Raspberry Pi 4 target. We now try to do the same exercise on a Aaeon Up x86 target board running Linux Ubuntu x86 64-bit operating system. The target is connected to the host PC through an Ethernet cable. We use Google Remote Desktop Sharing for viewing the target desktop screen. We follow the same steps as done for Raspberry Pi target. Our setup seems working as intended. Now, we will perform the same exercise on Aaeon Up x86 target board running Windows 11 64-bit operating system. The target is connected to the host PC through an Ethernet cable. Before running the CASP or build process, user may need to install dependencies and configure the system as mentioned in the readme_setup file. The remote desktop seems slow in updating the live screen. However, our program seems working correctly. With this, we end this video tutorial. Thank you for watching this video.